Alright, LabView is not hard. The point of this video is to walk through all four of the questions and make sure all of them are working, all the steps are documented properly, and to also prove that LabView is just easy marks, right? Because if I had to break it down, 85% of all of the questions is basically the same. You're just dropping the same blocks and making the same connections. And the fun fact is you don't even have to mug up anything. It's mainly and mostly intuitive. So I'm just going to go through all of the steps required for all four of the questions, and it'll just make sure all of the steps are there and the final output is showing for all four of them. So let's get started. It's pretty simple. And I'll be taking the first question, the PSK transceiver for um, the first try. And I'll explain everything here step by step for the first question. And then I'll also do second, third, and fourth, which will just prove that I'm doing basically the same thing four different times. The only thing, like I just mentioned, 85% of it is common for all four questions. There's just 15% that you have to change based on the question. So if I had to do a quick ranking, PSK is actually the is like the baseline. PSK and MSK are like almost similar. They have like about 8 blocks at every place. FSK is actually easier with like 7 blocks. Quam is harder with 9 blocks. But even though I say harder, it's very intuitive. If I had to break it down, it's basically match the following. That's all you have to do. You have to look at a block and see what name is given and correspond it to wherever an input of the same name is given. I'll be running through the entire thing, but I just want to prove that it's very, very simple and equally intuitive. So let's get started. This is PSK. Obviously, the first thing you have to do is hit Control T, and this will give you um, the flow. So I'm going to call this the flow because, yeah, this is what we'll be dealing with. And in the first 5 minutes, I'm going to first break down what exactly is going on, right? How are we supposed to comprehend what exactly we're looking at and what is important? Because, spoiler alert, not a lot of this is actually important. You only have to focus on what is important and you're allowed to leave the rest. So let's start with what's actually going on. This left hand side of the portion, this is your input. Okay, you have a lot of data, you have a lot of places where you can get inputs from. Not all of this is important. Okay, you just have to focus on whatever is important. I'll be telling you which of these are important. The rest of it in the middle, sorry, this main section is the flow. This is where you'll be putting in all of the blocks that are required. Like I said, 85% of the blocks and the connections are the same. 15% are here and there for different questions. And finally, you have the output section. This bit is the output section. So on the right hand side here, you have the data, or what I'd call the output data, which is basically what you need to make sure that you don't get any errors. So you have to make sure each of these over here, error out, transmitted, all of these have to have some connection at the end to make sure that you don't get any errors. That's what this section of it does. And this box at the bottom is what is for the output visuals, which means the final graph that you get, the red thingy with the dots, all of that is controlled by this block here. So if I had to break it down, this is the structure for all four questions. If I had to break it down very quickly, it would be 3 steps that we're doing, just 3 steps. First, you'll be adding all of the blocks and the connections here in the main set. Then you will be changing the you'll be making sure all of these have their particular outputs. This section you'll be changing, and then finally this box over here, you'll be figuring out this and making sure all of these connections are done as well. Let's cut straight to the chase. Let's not delay anything here. How do we go about this? Like I said, for PSK, there are a total of 8 blocks. 6 of them, or even say 7 of them, are actually common. So the way we do this is we first start by pulling the first block um, that you'll have to get from the path. So the path I'll be mentioning somewhere around. You just have to go to that path, which will be your C drive, 86, National Instruments, LabView 2020, vi.lib, add-ons, modulation, digital. This is where you will find everything. And for the first block, you'll have to go to support and examples and here. So over here, you will find mod whatever you require. By the way, to make your life easier, just by the time you reach here, digital, you just hit in the search box, you just type whatever name, if you remember the name, and I'll just find it for you. Anyways, you go to support examples and you find the first block, which is mod PSK. So where's that? Yep, mod PSK transmitter. Now this will change based on questions. So if you had QAM, you'll do mod QAM transmitter. That is somewhere down here. Yeah, mod QAM transmitter, or you'll do mod FSK transmitter or whatever. In this case, we want mod PSK transmitter, so you just drag this onto the screen. So the first step will be to make sure you have all the blocks put up. Before you start making the connections, put all the blocks. That's most important. Okay. Now this is the first block. Like I said, it's called the mod PSK. Quick hint here, if you hit Control H, you will get this context block help, which will give you the names of all the blocks. The next three are common again, and luckily enough for all four of the questions, those are written right on top here. This AWGN, add IQ impairments, and PSK demodulation. So another place where you can find all of these quite easier, much easier, is if you right click anywhere on the screen, you get this, hit search and hit AWGN or whatever you want to type. Now, if you don't find it here, this is the search palettes option. If you don't find it here, then you'll have to go to the path thing and find it. Anyways, you take this, you've got AWGN, this is your second block. Similarly, you'd want apply IQ impairments. Yeah, and I repeat, these blocks are the same for all four experiments. Apply IQ impairments, and then the demodulation block. This you'll have to find in the File Explorer again. You go to digital, you can either type it here, or I already know it's in demodulation, and demodulate PSK. Again, if it's QAM, then you'll do demodulate QAM and whatever. You drop this here, right? So this is TX, and you have to remember this in order, though. This is important. So you've got this. After this, again, one more common block for all cases is the EB not. So capital E, small b, capital N, 0. Calculate EB, whatever this is. Put this here and put this on top here. Now, what's more important is also how I'm placing it, because that will make the connections easier. Yeah, also over here, you'll have to change it based on your modulation scheme. So I'll be putting PSK here. After this, you put 5 blocks here. You'll have 2 more blocks to add. You'll have to find it here. You'll have the block PSK measure PSK. Oops, what's going on? Oops. Where is that one? Sorry. Digital measure PSK. Measure PSK quadrature impairments. This one. Okay. You drop this. Again, for QAM, it will be QAM impairments. This block is missing in FSK. We'll talk about that later. But yeah, this is there. And then finally, you will have to also add, of that you can find in palettes itself. Calculate PER. This, if you remember, this is the only thing that you have to mug up. Okay, after that, all of the connections are just intuitive. It's all match the following, like I told you. You look at the output and you see where the matching input exists. That's all you have to do. Okay. Now let's get started. That's 1, 2, 3, 4, 5, 6, 7. There's one more block that you have to add, which is called unbundle by name. Unbundle by name. You add that here. And what you'll recognize is smaller. So what you have to do is right click here and click add element about 6 times. You do that till you have 6 elements. And yeah, now that you have 6 elements, this is done. Unbundled by name is also ready. Now, let's talk about how the connections are made. We'll walk through this step by step and everything should make sense. This is the block that generates your waveform. Okay, this is your transmission block. This generates your waveform. Okay, it takes a particular set of inputs and generates what is known as output complex waveform. Okay, it's the pink line that you'll notice, and that is that is what is actually flowing from left to right. You are changing the waveform. Okay, and this is the block that generates it. And so all of these inputs on the left, you have to connect a few and you have to leave a few. And it's very simple. Look at this. It says symbol rate. You just find anything on the left that says symbol rate, which is like right here. So you connect this to symbol rate. That's all. Next, you've got PSK. Now again, you just find anything on the left that says PSK. Over here, it's this block. You'll have to move around a little bit to make it obvious. This is, look, you see differential PSK, PSK type. This is where you get your PSK input from. Here, output cluster, and you put that in here and you get PSK input. Message, again, just find anything on the left side that says message right here. This is it. That's all you have to do. You just keep looking for where it exists on the left hand side and you just match. Again, now I have system filter that exists. Yeah, this might be somewhere behind. Oh, never mind. Sorry, it's here. Yes. So see, I don't remember where it is. I just look for it and see, oh look, there's TX filter that's right there. Take this and drop it here. Done. And error in. So about the errors, the error is also just one flow. So what happens is all of the error outs connect to all of the error ins. So each block has an error in and an error out, and you just connect the error out with the error in. Similarly, error out with error in, like this, just make a train. Anyways, that was overhead. So that sets the inputs here. You see a few more. See now reset. Reset is a common line that's present here. This green line over here. This is reset. Every block has a reset button, which is, look, you can see this reset here, reset here. All of those have to be connected to this green line. Samples for symbol. Again, you just look for where you can find samples for symbol. It's right here. So you don't have to connect it here. You can just connect it anywhere on this line. Click on this and just connect. That's all. You're just doing that every single time. Now the outputs, the most important, like I told you, is output complex waveform, and this is also just a train. So you're just going to connect this to this. So output complex waveform connects to input complex waveform, and this keeps connecting like this. This keeps connecting like this. That's all. Anyways, so you connect this, and again, like I said, it's better to go step by step. First one block, then next block, then next block. That's better. Signal description, this is not inadvertently present here. What you'll have to do is take this and put it in unbundle by name. This is the one thing you'll have to remember. You click this and you get 6 of these. Okay, this is what you'll have to change. And again, this is also pretty simple. First one's output bit stream. Second one is whatever after the output bit stream. Third one, you have sync bits and sync symbols. So you choose sync symbols. Then you choose the one after that. Then you choose the one after that. And then you choose the one after that, which is this. You just click all elements. That's all. Okay, oops. Yep. It's literally an order. Output bit stream, number of bits per symbol. Between these two, you choose sync symbols, this, and then this. Click all elements, right? That sorts out. Oh, come on. Yeah, that sorts out unbundle by name, and that's pretty simple. Now let's move on to this block. Now, what needs to be recognized moving forward is that some nodes will be missed out, and recognizing which nodes will be missed out is quite important, because again, they'll be missed out for all 4 experiments. Like for example, this one, there's error in, there's no block before this to give you error in, so this error out will just connect here. Okay, now let's talk about this one. As we go on, even you'll recognize the pattern, which nodes are missing or which nodes we didn't connect, and those are the nodes you'll be missing every single time. So just remember that. Again, now we'll have samples per symbol, again, very obviously present. That's all you have to do. It's just this. It's just looking for what the name says and finding where it's present on the left hand side. Yeah, next we have bits per symbol here. This connects to bits per symbol here. Again, just keep doing this, right? You can drag around to make it look neat, that's all. EBNO, it's present right here. And yeah, the more you just keep doing it, the more you just understand where the stuff exists. And it's just copy, paste, repeat after that. Yeah. After that, like I said, output complex waveform is direct connect. It's a train. Yeah, seed in is one of the things that you'll not connect. Okay, it says the seed in here, there's a seed out here, leave those. Reset connects here, error out connects here. This is just, that's all, you just keep doing this. Yes, now coming to this block, there are a total of 5 inputs that you do not connect, and just remember these, this Q, DC offset, IQ gain imbalance, quadrature skew. Just, if you want, don't remember the names, just remember these 3 on the left and these 2 on the top, because this block, add IQ impairments, is a common block for all 4 experiments. So you will commonly not connect these 5 for all 4 experiments. The rest of them you'll connect. Again, output complex waveform, input complex waveform, error out, error in. It's just that's all. Reset, yes, please. Frequency offset, it's here. It's frequency offset. That's all you have to do. That's all you have to do. Okay, like I said, these 5 you will not connect. Here you decide not to connect, seed in, seed out. Here you will not connect, error in. Okay, here this is the demodulation block. Here you will connect everything. Okay, let's see. PSK system parameters. Oh, there it is. Again, it's just this. Match filter coefficients, there it is. The only place you will go wrong is if you misconnect something. That's the only place you'll go wrong. Synchronization parameters, this is one important thing. This will come from here, from sync sequence. This will come from here, and sync sequence in itself needs to be connected to sync symbols. Okay, you take sync symbols and you connect it here. Yes, this is one thing you may have to remember. Okay, but again, the naming is literally the same. Synchronization parameters you find in sync sequence matches with sync numbers, sync symbols. That's all. Okay, then you have pulse shaping filter coefficients, which is here. Reset, which is here. Recovered complex waveform goes to this recovered complex waveform. This is it. Output bit stream goes to input bit stream. It's just the same. Okay. Measurements, yes, this is important, where you'll be connecting measurements to frequency offset right here. Okay, and this frequency offset gets connected. I'll connect that later. Let's not talk about that. This measurements gets connected to frequency offset. Okay, sync found index, that will be connected somewhere here later. But again, if you want to, then it's just the same thing. You say sync found index, you see over here it will be written, it's not properly written here, but last sync found index, right? That's where you connect this. It's all about knowing where to connect it. Never mind. What remains? Error out, error in. Simple. Now you see there's nothing that's not connected here. Let's talk about EB naught. This is received waveform, which is the same thing as the train that we've been creating here of output complex waveform, input complex waveform, all that same thing. And just it takes a little bit of received waveform. PSK system parameters is just this same line again. You can just choose how to connect it. It does not matter where you connect it on this line, as long as it's connected to the right line, it's fine. That's all you have to do. LabView will handle all of these connections on its own. Just make sure you're connecting it to the right line. That's all. Synchronization parameters, again, it's this one, it's this line. Like I said, synchronization parameters, sync sequence is this one. Match filter coefficients, it's this one. So, oops, I think yeah, sorry. So don't directly connect it, just connect it to this line. Yep, connect to this line. Error in, yeah, you just borrow it from here. Yeah, it's just like drawing currents and stuff, that's all it is. Pulse shaping, filter coefficients, it's this line. It'll handle all of the routing for you as well. That's very simple. Okay, now between EB naught and EB naught DB, you'll have to connect the DB because it literally says DB here. Error out, you can connect that. Okay, I don't think you have to connect this error out. That's all right. So the thing is, this error out is not very important. It's not extremely important, but sometimes it gets important. But for now, it's fine. Okay, so just leave it. Now we'll see what else is remaining. Yeah, there's a reset. For the error train, right? I'll explain how this works. Is the errors you'll have, oops, yeah, the errors will be flowing from here, like from one block to the next, right? And over here you have only one error out, okay? So you'll be sending this error out here. The thing is, if you have multiple error outs, you can't just merge these two. That'll be uh, yeah, that'll cause an issue. You can't merge your error outs into an error out like this. So if you have only one error out here, you just connect the one error out line, and that's fine. Um, if you have to leave any error outs like this, it's fine. That's not a big issue. Yeah, that's about it. Now we keep moving on. In this block, right? Things like this impairment measurement window, you don't connect. Okay, you just have to remember what you don't connect. That's more important. Impairment measurement window is something we're not going to be connecting. PSK system parameters, yep, it's the same thing again and again. Magnitude error will also not be connecting. DC offset measurements also will not be connecting. These three we will not be connecting. Again, same thing. IQ imbalance, nothing. Phase error, nothing. EVM, not in this case. You'll not be connecting it here. And see, all you have to do is just connect it when you see the names coming up. So neither of these you'll have to actually connect. Modulation error ratio dB, that's right here. Okay. Yeah, you can leave all of these. There's a reset here, so you can correct that. Oops. Yep. Impairment definition, quadrature, Q degree. Yep, you can leave all of this. If you want, you can remember the number of, instead of remembering the names, you can just remember how many you're leaving. Remember 1, 2, 3, 2. You're leaving these many dots on this block. And again, that's mostly common for all cases. Okay, now we'll come to IQ. Okay, so now here this block doesn't continue the train, because when you see this received recovered complex waveform, that is the final output waveform. Okay, so we don't have to connect to this again. This is a different block. This is your final output complex waveform, and the way you do that is connect this to output complex waveform. This is the end of this train. So you see it started here, this pink train, it started here, goes all the way through here, and once this final connection has been made, this is the recovered, this is called the recovered complex waveform. You just connect it here and you're done. Simple as that. Okay, that is it. So now you're done with most of the blocks. Yeah, this is one block you have to finish connecting. Again, now input bit stream. If you recognize, this is also one of the most important lines here, output bit stream, input bit stream. This will be something that will be connecting all of the place and overall for experiments. So over here you can see you want an input bit stream, right? So you pick it up from here, input bit stream. This is the blue line. The blue line represents, blue thick line represents input bit stream. Okay, PN sequence order not required. None of these are required. And you just keep doing this over time, and you'll understand which ones are not required. This is a reset, not required. Yeah, BER is right here. BER stands for bit error rate. Over here, a nice way to remember it is every alternate one gets selected. So BER gets selected. This one is not required. Trigger found gets selected because it's right here. The next one doesn't get selected because we don't need this. And the next one gets selected. This is error out. And that's about it. This is all of the connections intuitively. There's nothing I memorized. I'm not looking at any other screen here. It's just doing match the following. That's all it is. Okay. Now the final thing, there's one more block that you'll have to correct every single time for all four um, experiments, is align array. So align array has these two, TX bit sequence and RX bit sequence. TX bit sequence is output bit stream right here. This goes into TX bit sequence. And oops. Yep. And that's not important. I'm just doing it for the sake of it. And RX bit sequence is the same, output bit stream. Okay, this is this. Now that sorts out align array as well. You have this thing called received bits. This is also the same. This is the output bit stream. So you see, two things are the most important here. You have the complex waveform. The output complex waveform, and you have the output bit stream. These are the two important ones that just are seen everywhere here: the pink lines and the blue lines. Okay, now coming back to our flow, right? We've put all of the blocks together. Every block has all of the important dots aligned. What you have to do next, like I said, is make sure all of these are connected as well. All of these need to be connected. So you see, this is connected. We missed frequency offset, so this is this one, right? Like I mentioned here, this is measurements from this PSK demodulation block. This gets connected to frequency offset, and this gets connected to frequency offset. Simple. Look, we missed PSK system parameters here, so you just um, connect it. That's all. Modulation error ratio, everything's connected. You miss status here, which is the same as error out. Okay, this is just saying that if sorry, there's one more line you missed here. This goes into this OR gate. So this is just saying that if error is equal to 1, then you will hit the stop button, basically. That's what it is. This status OR gate with this stop symbol, it will stop the entire process. This is 2/3 of the job done. The final job that you need to do, like I mentioned, is this output block here. This needs to be changed. And if you haven't noticed, this is actually a scroll bar here. You'll have to change a lot of things here, at least 5 or so blocks. And like I said, this is responsible for the output. If you check this, each of these here, transmitted symbols, demodulated symbols, they all correspond to something here. Look, transmitted symbols is here. Constellation RX output will also be here. That's all you're doing. You just have to make sure all of these outputs are coming correctly, and this is the block responsible for that. Now let's talk business. Let's start with transmitted symbols. And again, over here also, all you have to do is focus on the blocks, nothing else. Everything else is connected for you. Just focus on the blocks and which dots are missing. That's all. In this block, we'll have to connect bits per symbol, which is the same thing here. You can see bits per symbol is right here, and you just connect it to this line. Like I mentioned earlier, you can just connect it to the line, and all of them correspond to the same one. And again, over here in this section, you'll have to only focus on the blocks, these small blocks here, and which connections have not been made. We move on to the next one. There's demodulated symbols. In this also, some 2 connections need to be made. Let's talk about which ones. Okay, we have bit stream. Bit stream is equivalent to the output bit stream, this one. Like I showed, output bit stream. You can take any line from here and you can just drag it in here. And this is bits per symbol, which is the same as this line. So bits per symbol, simple as that. Yes, we move on. TX spectrum in this FFT mag block, we have to deal with this. Input data waveform. Now, this is important. There's an TX spectrum and there's an RX spectrum as well. This eye diagram. So wherever it says TX, right, the data waveform that we'll be connecting is the initial waveform that we created. So I'll reconfirm what I just said. This part, this recovered data waveform, this line, this is the output complex waveform. This is the final waveform that we'll be observing. This line that you've got here, this is the initial waveform that was generated by this TX block. So for TX spectrum, you'll be picking up this. For RX spectrum, or anything that says RX, for this there's an input complex waveform here, you'll be picking the final waveform. So this is the final waveform line, this is the initial waveform line. Okay, so let's do what I just said. In TX spectrum, you have FFT mag. It's asking for an input data waveform, and because it's TX, I'll be picking this waveform. Okay, this is my input waveform, as in the waveform before all of the stuff that's happening here happens. This is the input waveform. Okay, and this goes in here directly. All right, there's this FFT size and phase. You can just leave these. Yes, in Constellation TX output also they're asking for a waveform. Again, like I said, this is TX. So TX, you'll have to use the input waveform, which is this. Okay, in the RX output, okay, it's asking for, again, input complex waveform, but I'll be giving the final waveform that's over here. This is the unprocessed waveform, you can call it, and this is the processed waveform. So in the RX output, you'll be giving the processed waveform that's here, and in the PX, I've given the unprocessed waveform, which is here. Okay. Constellation RX output, this will be the processed waveform, which is right here. Okay. Just make sure no other blocks. This is error in, error out, not always important. Again, this is Rx here. So the waveform that you provide to them here is this. This is the dot that gives you this. Nothing else is just error ins, no problem there, and that's done. One thing I would like to note is you would see that when you're on one page, some of these dots don't have lines. They just mean that these lines correspond to some other page, and on this page it's not important. So don't look at these dots as this line coming in onto this dot and then this dot extending inwards. That's how I used to look at it earlier. But this dot right here without any line inside just means that maybe on a different page it's actually being accessed like this. That's all. Now that's everything I've done. I'm hoping I've also done it right. And the way you can figure out if you've done all the corrections is this arrow over here will become white. If you've noticed, if there's something that's missing, for example, let me just delete this, then you'll get a broken arrow. That's not what you need. Okay, and if you do get a broken arrow, if you click this, then you'll get some errors. It says unbundled by name contains wired or bad terminals. If you point out to it, it'll probably even point out, look, it'll just say which part is missing. So you just make the connections. But this is not confirmation that your thing will be working. This is just confirmation that there are no errors. It might actually still not work. But let's give it a try. You open this window and hit the run button. And there you go. It's working. To make sure everything's working, you need to have this the red thing in the middle. You have to have these, you have to have these. Your TX spectrum should be constant and not wavering. This is good. This is also good. And this eye diagram needs to look good. So your teachers will be looking for this eye diagram and the constellation RX output. A good Viva question will be what these mean, so preferably learn that. And that is it. This is PSK done in, I don't know how long I've been recording. 36 minutes. Okay, that is one experiment done with everything. Now I'll be doing this same thing for the next 3 experiments and you'll see how quickly it gets done. Watch me. I'm just gonna hit don't save because it does not matter. Oops. And now let's open the next experiment, which is QAM, I suppose. Yep. Okay, let's start with empty QAM now. And now you will completely understand how the procedure is literally the same, apart from say 15%. You might remember me saying in the beginning that QAM is the hardest of them all because in PSK we had to do 8 blocks. In this we'll have to remember 10 blocks actually. But again, the same blocks, just 2 extra blocks that you have to remember. Let's get started and I'll just speed run this now to just show you how easy this is. Yeah, again, same things again and again. I'll just finish this just for documentation's sake and to just make sure everything's working. No, sorry. National Instruments, LabView 2020, VILib, add-ons, modulation, digital, support, examples. And over here you'll pick up mod, QAM transmitter. Alright. Let's just see, names are pretty simple. Apply IQ. And the COM demodulation you will find here in demodulation. Empty demodulate COM. Yes. Then you will not here. So you have to pick it from here. EBN naught, calculate EBN naught. When you do this, just make sure you're changing the name to what's required, com in this case. After this, it's the same. One more you have to pick from here, which is measure quam quadrature variance. Okay, over here you will be adding two more blocks. Sorry, before this, just add the one that we already know of, but we'll just add that here. Over here, now we will be adding two more blocks. One of them is called modulate quam. Modulate quam, this this block. What did I do there? Yeah. This block goes here. Again, the order is quite important. It will make sense in a while. Yeah, this and one more block, which will be row. Calculate row or measure row. And this is easy to remember. Just know that you'll have to have one modulation block after the demodulation block. And this row, you can see that there's one extra input here that was not present in PS game. So that is why you need this extra block. And now it's the same connections all over again. Let us get started. Symbol rate, direct connection, MCOM. Now MCOM is not directly visible here, but it's here actually, MCOM. You see that this line goes into whatever this is. So this is where you actually have to pick up MCOM from. Message right here. One small thing to be added here. Oops, one small thing to be added here is that for blocks like these, it's better to pick it up from here. I'll explain. It's better, instead of connecting it somewhere back here, which will actually cause issues, you connect it here. This is where it's actually supposed to be connected so that it does not cause any other issues. System filter, TX filter right here, error, do not care, reset, and samples per symbol, output complex waveform, forms the strain, signal description. I completely forgot about unbundle by name. Unbundle by name. So again, it's not even something, it's intuitive. You see what you missed out and you just add it. It's that simple. And it's the same story 4 times. That's all. Signal description, there you go. You'll be changing the names to exactly what they were before. Sync symbols, this, that, and this. Yep. Moving on. Error out gets connected here. Okay, the samples per symbol connected here. Bits per symbol, there you go. EB naught is there. Reset is here. And as you can see, seed is here again. Like I said, these blocks are definitely used all the time. So you'll be not connecting these same blocks again and again. So seed in, again, I'm not connecting. Error out goes to error in. Output input. Now again, like I said, IQ impairments again, you do not want to connect these 5, so just don't connect those. This is there. Yeah. This is there. This is reset. Yeah, do remember there are dots on all, there are nodes on all 4 sides of the block, so don't forget. Like example, this one. This is one that's commonly forgotten. QAM system parameters right here. Okay, now this is the demodulation block, and remember, in demodulation block, all nodes have to be connected. There is no node that is left unconnected. Match filter coefficients, synchronization parameters, like I said, it's here, and this gets connected to sync symbols. It's the same thing as last time. Reset, yes please. Receive a complex waveform, goes to this, and this is your processed final waveform. Like I mentioned, this is the processed waveform and this is the unprocessed waveform. Right. Input bit stream is output bit stream. This is your second most important line in the flow. Again, these will you not connect, these will not connect. Reset. All these impairments and all of these DC offsets, just don't connect those. Com parameters, just connect the ones that are familiar. Should I mess up? Yeah, so don't directly connect it here if there's already a connection. It's better to connect it to this line instead, otherwise it will cause issues. Magnitude error, DC offset, don't care, don't care, don't care, don't care. This is important. Modulation error ratio, and again, you just know the ones that are important if they're mentioned somewhere else on the flow. That's the easiest way you know something is important. Error out, quadrature skew, impairment definition. Like I said, for this block, just miss exactly the same number of things here. You see there's an extra EV normalization type, that's not important. This EVM is actually important, but because I can't see where to connect it right now, I'll leave it away. And again, you'll immediately notice where it needs to be connected later. Yeah, this is fine. Input bit stream comes in through here, simple as that. Now this is the reason I put this here, is this PN sequence order 9. Now, in PSK, you notice that this was not available in the block, but because it's you will notice that this block was not automatically kept there. Hence, we ignored PN sequence. But in this case, it is given, so you will connect it. It's as simple as that. Just make sure all of the things are connected. None of these are important. Over here, like I said, in this, it's you can just make sure you know that you're connecting every alternate connection. BER is right there, you don't need this. The third one you will need, it's right here. You don't need the fourth one, and the fifth one is error out. Now, the one important thing that I was mentioning about error out earlier is this block. Now, this block is taking all of the error outs, ANDing them, and putting it into error out here. So, unless you see a block here, then you will have to make the error out connections. Okay, if this is not present, then it's fine. You can just leave the error. You can leave error out of one of the two blocks without it, and that will be fine. The error out connections become important if you have blocks like these that are ORing or ANDing the connections. This is actually an OR gate and not an AND. You'll be ORing all of these inputs and putting it here. And the OR train will look something like this here. You'll be connecting this here, you'll be connecting this here, and this here. And that's all. You just have to make sure there's no connection that's not connected. That will be a problem. And this is error here. If this is all connected, then we will move on. Yep. There's one on top here. This received waveform. Received waveform is this block, this one here. And that is why the order is actually important. Order in the sense I have placed EB0 right here so that I know that received waveform is this line, not the recovered line, not the final processed line. It's the line before this. So that's the reason the placement is important, and I always place it right before this estimated EB0 so that it's just easier to connect. What is going on here? Yes, thank you. Com system parameters is just this line here. Oh, this is getting confusing, so I will pull this down here to make life easier. Synchronization parameters, like I mentioned, it's this line. These things are literally not required. Match filter, there you are. Pulse shaping, there you are. EB0, okay, like I mentioned last time, EB0 you'll be connecting the TB, not the top one. And what is this? Reset. All right. Now you have this. This is the modulate block. You have the input data stream, so you will connect this. Com system parameters, so you connect this. Symbol rate. Symbol rate is symbol rate. Yeah, this is the one. So this is your symbol rate. You'll be connecting this all the way here, and thankfully it does all the connections for you, so that you don't have to break your head trying to do things. Pulse shaping filter coefficients right here. All this also that? Yep, it is. um, reset. Yes, please. Um, this we'll deal with a bit later. Yeah, okay. Now, what we have here is output complex waveform, and the reason I'm not immediately connecting it is this. This block has a few things to connect. This has a received complex waveform and an ideal complex waveform. The way we work with this is something to be remembered. The output complex waveform from here gets connected to ideal complex waveform here, and the received complex waveform comes from the recovered complex waveform, which is here. This is how you work out the math here, so that is important, you know that. Row direct. Oh, there's one thing I missed here, measurements. It's this normal. Yes. Making sure you do not miss anything important on all of the sync fount index. Forgot this. Yes, just making sure again. Not missing anything important as of now. These are all not important, not important, not important. Symbols out. Sorry. I believe that's not important because I didn't see symbols out somewhere here. Yeah, flush buffers don't care. Now that this is done, we have to make sure all of these are connected, for which you have to make sure align array is connected. So align array, like I mentioned earlier, output bit stream is the TX bit sequence, this, and the RX bit sequence is the standard output, this output bit stream, the normal one. And you have this one, this received bits, which will be here, direct. This is the same output bit stream, same thing. That is done. All of this is done. The last thing we have to do is this visual block here to make sure everything, all of the visuals are correct. Just make sure all of these are right. Bits per symbol. This line here. Directly connect. Nothing's going to happen. You need bit stream. So bit stream again comes from here. Number one. Yeah, this might be slightly confusing. This is the output bit stream, and you connect that here. And bits per symbol is the same that came through here. So I'll just extend it out here and connect it. Okay, all of this doesn't matter. You just randomly connect it also, it will work. Just make sure you're connecting the right lines. Constellation TX output. I think I've already told you the way this works. Is if there's a TX here, you will connect to the unprocessed waveform that is here instead of anything else. This is what you'll be connecting here. Nothing else is important here. You have, yeah, the reason over here error in will be important is because this block has its own error out. So just make sure you just connect error in from anywhere, doesn't matter. Again, this is not important. If it draws an error, then you can drop this, otherwise it's fine. Moving on. The trunk filter, this is the RX output. So in the RX output, you have to just take in the recovered complex waveform. This is the final one and the more important one, right? You have error in, just connect it here, does not matter. Moving on. I diagram. You see, I diagram RX is also here. So you will be connecting the recovered waveform, which is this. Yep, take this, done. Error in, just connect it. So that doesn't give any errors. EVM. Now you see that EVM is suddenly important and you realize EVM is here. So you can correct this. So I didn't immediately notice EVM anywhere else, so I didn't do anything about it. So I didn't think to care. But now that I saw it, I will try to correct it. That's how intuitive and simple this thing is. Now, there were a lot of things that we did here, hoping that it's actually right. Let's see. Now you can see the arrow is gone, the arrow is solid, and this is correct. Yep, there you go. You'll see everything is correct. The eye diagram is perfect. The eye diagram should look like this. This is more important. There should be these thingies in the middle. 16 dots, that is the constellation RX output should look correct. This is your input, does not matter. EVM should be looking all right. Yup, this is exactly how it should look. In case it is, I will just confirm with the working codes. This is the working code, and yep, it's the same, absolutely the same. Your RX output should look like this, your I diagram should look like this. That's all. It's exactly the same, and you can see how quick that was. It's that's all it takes. That's just the same thing again and again and again. Just keep doing it. Don't save, don't care. Moving on. Let us take the third in this sequence. FSK. FSK is actually easier, but it's got a few kinks to it. So let's talk about this. And again, you will actually start recognizing what the kinks are as they happen. All right, FSK is actually simpler because it does not include one block. And as we go about it, we will know which blocks we are missing. Digital support examples. Mod FSK transmitter, thank you very much. Take this, and then you'll have AWGN. Add that here. Apply IQ impairments. So it's just important that you take an hour, probably finish this entire video. Hopefully this is less than an hour long. That will be an achievement. And do this, look at the entire video, and then apply it yourself, and then you'll get a complete understanding of how this thing works. Digital demodulation. Demodulate FSK. That goes here. And then you have the EB naught, which is also here. EBN naught. This same thing again. Nothing over the top. The thing that's missing here is the block that comes after this usually, which is the measure QAM impairments, whatever that is. FSK does not have that block. Or it might, I don't know, but you don't need to add it here. Yeah, so the block's name is empty measure FSK impairments or something. Quadrature impairments, that's not here. So it's quadrature impairments, that's not here, so we do not need that block. Remember that. And that's the only kink here. That's all you have to make sure. Where is it? Did I close it? I did. Yes. National Instruments 2020. VI. This will just come through practice. It's just an hour's. It's just an hour's practice, max 2 hours. If you have time, you can do it. We need what now? We need. We only need to calculate PER. That was here itself. Yep. Now you can see 1, 2, 3, 4, 5, 6, and the final one is unbundled by name. So you can remember this way. PSK is the standard size with 8. MSK is also 8. Sorry, MSK is also 8. PSK is 8. FSK is 1 less with 7. Quadrature is 2 higher with 10. So that's how you can remember it. That's how I remember it. Continuing, let's see how quickly we can do this one. Symbol rate. There you are. FSK specific. This is one important thing. Okay, this was where I actually got stuck for a second. Okay, I don't see. Yeah, FSK. So you see that there is already one line coming out of this, right? It looks like there's a line coming out of this, and you'd be right to some extent. But the thing is, there's actually not a line coming out of this. This line is actually connected like this. It's connected to the other side of this. So do not make this. Do not make this connection. This is important. Do not make this connection. You will have to make a connection directly to output cluster. And the way you know that this is not connected to output cluster is this dot here. This dot only comes to places where connections have not been made, right? So you see that there's a dot here. The connection has actually not been made, and this line is uh, erroneously pointing in the wrong direction. So yeah, you just have to connect this to FSK specific. That's about it. Similarly, look, it's the same case here as well. Look, this line looks like it's connected here, but if you put your cursor, you see that dot, this dot here, which means it's not actually connected. So do not make this connection. I already did this and I failed. So yeah, make this connection. Message. Similarly, one more final time, it happens with TX as well. Look, it looks like this line is connected here, but you connect this instead. Right? Error in does not matter as of now. Reset. This is important. Samples per symbol, you will not actually find it here. You will look at this and be like, hey, where to go? Samples per symbol is actually this line. This extra block here is actually FSK samples per symbol. This line is now samples per symbol, and this you will connect it directly here with no problems at all. This gets connected here, same description gets connected here, same thing. Yep, this is this. Signal description, error out gets connected, error in. Samples per symbol, this is the same thing. This is called samples per symbol. So you will connect this. Bits per symbol, this. EB naught, that is on the other side. Feel free to just put the rest of this video on 2x because it's the same thing. Reset, yeah, please. Again, the C3 will leave because that's always been left out. Again, these 5 you will leave. Error out. Modulation block, we will always connect everything because that's important. Match filter coefficients. Synchronization parameters, that's here, and this will connect to this. Just might not have connected the right way. Yep, just try to cross check. Recovered complex waveform. This is important because this usually goes to that block which is the measure quadrature impairments, but that block is not available here. So this can directly, this being the final recovered waveform, the process waveform, can directly go here. Output bitstream, again, there this is there, so you have to make this connection. PN sequence. Now you remember in QAM there used to be a block here that's not there, so you don't care about it. Just making sure you don't really care about it. Yeah, you don't. What else is here? BER, come with whatever. Do not care. Reset. BER is this. You will only connect the alternate pairs. Trigger found, yes please. Error out is now you see this. Now this block also exists here. Remember this was in QAM. You have to make sure this doesn't. You have to make sure this does not create errors. So the way you do this is you'll have to merge a few of your errors. Yeah, okay. So you have only one option here. So you will just leave this error. Does not matter, like I said before. Receive waveform, it's this one. Like I said, it's not the recover. Oops, sorry, I think I connected it one too far back. But again, I think that's the same. So you connect it here, not this one. This is the output complex waveform. Yes. Yes. Yeah, what else? FSK system parameters, synchronization parameters, mash filter coefficients, that's here. Oh, matched filter coefficients. Error in, just errors don't really matter as much as long as everything's correct. Pulse shaped filter. EV not TB, error out, you can leave it because you do not have space to give it. Yep. Oh, I missed this again. Sync found. Oh, look, see, I missed this as well. So, see, you just have to make sure you don't miss nodes. That's important. Sync found, you can leave that. Oh, no, sorry. Yeah, see, again, I'm not marking anything up. I'm just looking at it and realizing what's to be connected and what's not to be connected. All of these can be connected. All these can be missed out. You can be connected here. Align array has to be connected again. So output bit stream goes here. And this one. This is your output bit stream. This is the main bit stream. This comes in through the RX bit sequence. And this also connects this. And error out is already connected. If it doesn't look like it's connected, it's already connected. Everything that's connected, all you have to make sure is this now. I diagram. This is your RX, so you have to make sure you connect the recovered, this one, the final processed waveform. So I will connect this here. Another thing, unimportant islands, match filter coefficients, that's important obviously. So I will draw from here, drop that. This error again may or may not be important. I've never tried not connecting it, so output FM demodulated waveform does not look like it's important. Transmit spectrum input data waveform. This is transmit. This is TX. So you will be connecting the this one. You will be connecting the unprocessed data transmit spectrum, right? dB on off, FFT size, phase, not important. Received spectrum again. Input data waveform. This is received spectrum. So you will be connecting the output, the final processed waveform, right? None of these is important again. That's done. There's a there's a broken arrow, something missing. So yep, this is what I missed. This is what I said I would connect, but I did not. So yeah, this is your OR thing. So you have only one space here, hence I left this error out. So that's okay. Because if I try to put it here, then this will create issues. Let's not do that. And if this is right, it should run. There you go. Absolutely everything is right there. This eye diagram looks slightly weird, but it's supposed to look weird, so it's fine. This is the thing that they notice the most. So that's MSK for you. Don't save. Moving on. Final one. Do I have less than an hour? Probably do. Where is the last one? CST files. MSK. Hoping this video is actually less than an hour. That'll be helpful. Control T. Let's begin. MSK is basically PSK. Nothing, very, very few things that are different. I will talk about what is different. We go to support, examples, mod. What is it called? MSK. Begin we shall. Okay, now you will put AWGN there, IQ balance, MSK demodulation. The same number of blocks go in this. That is why I was saying this is the same. 8 blocks. So MSK, as it's in demodulation section. MSK. MSK goes there. I'll just create some space so that I can put the EB naught. EB and not calculate. That'll go here. That'll always go behind this MSK. 1, 2, 3, 4, 5. You need the yes. So you will need this measure MSK quadrature impairments. This was not available for the FSK, so we'll remove that. And then PER. Almost done. So the final stretch. Let's go. Symbol rate connected. Differential encoding. Either it's there, it's not. I'm not sure. No, I'm going to skip that because I do not believe differential encoding exists. Message. And again, if I'm wrong, then it will tell me that there's an error. System filter, yes. Error in not required as of now. Reset, please. You will notice the same thing with FSK exists here. You will see that this samples per symbol is actually existing here instead of anywhere else. And as usual, I missed unbundle by name. The only change that comes here is that instead of creating 6 unbundles, you will create only 5. Okay? Yep. And the reason for that, I will make it very clear. It's not like you're mugging up anything. It will make absolute and pure sense. Yeah. The reason you do that is because over here, now you will avoid the number of bits per symbol. You will just continue on with this. The reason for that being is over here, you will have to eventually, just now make the connections. Eventually you have to bring in this bits per symbol. Usually it's number of bits per symbol or just bits per symbol, and you would connect it in bits per symbol here. The thing is, over here they've given a new input, bits per symbol 1. This is important, and you will connect this directly here instead of what comes through this. That's the only difference. Everything else is the same. Okay. Everything else is the same. Seed in, you will miss again. You will miss these 3, you will miss these 2. Reset, please. This is frequency offset. Where to go? MSK system parameters. Match filter coefficients. Synchronization parameters. This is high up here for whatever reason. Again, this might bring the same issue. Like you see, this looks like it's connected here, so do not just do this. This will cause issues. It looks like it's connected here, but you see there is a dot at the end here, which dictates that this is an empty node. You will have to connect the node directly to synchronization parameters. Okay. Something called detected complex waveform here. That's different, but that's okay, because there's a direct node for that here, detected complex waveform. That's about it. That's all it is. You just see what matches and you just connect it. Output bit stream. Is there an input bit stream here? Should be. It doesn't seem to be, so it's fine. Measurements, frequency offset, and this. Might not have connected the right way. Impairment measurement window, leave all that, leave all that, leave all these. Sample per symbol, that is this line here. Over here also you'll see samples per symbol. Ignore FSK. This is samples per symbol line, which will go here. This too can be ignored. You can be ignored. You can be ignored. EVM might come later. Not sure, but again, you'll know when it will come. Modulation error. Error out goes into error in. Same with this. Yep. Input bit stream, which comes from here conveniently. PN sequence number not required anymore. Not required. What are you? Not required. Reset, please. BER important, this one not important, this one important, next one not important, and next one important. If you remember, this status thing is similar to what we had in the PSK, where we will just directly connect this and then connect this to this. And that's about it. We're almost done. What this block is meaning. Received waveform connects to this, not the recovered waveform. MSK system parameters. Synchronization parameters. Okay, they're not connected to this. You will have to connect it to this. Yeah, so this is right, so something is, yeah, I think you've connected to this one. Yeah, so see, this gets connected to synchronization parameters, and then you connect this line to synchronization parameters. This seems to be different lines, so do not mess with that as of now. Yeah. Match filter coefficients. Yes, please. Pulse filter coefficients. EB number. And error out, there's no place for error out, so that does not matter. That should finish most of it. You see this recovered complex waveform. You will take that and put it here. Anything else? Oh yeah, align array. Just make sure you get that one. TX bit sequence is output bit stream. Received bit sequence is this line that's here, and this is also the line that goes into received bits. Everything else is dealt with. You have to only deal with this one remaining. You see TX here. This needs to be connected to the unprocessed waveform here. Error out does not matter because this block does not have an error out of its own. Transmit symbols. What is required? Nothing here. Why there's so many things here? Yeah, you only need bit stream here, which is received bit stream. Right? That's the same. It's the same line that goes here. And about that much. Trellis graph. This is TX, hence you will have to connect the this one, just so that it's clear. You have to connect this one, and there's a trellis RX, which will come later, I suppose. Yes, MSK constellation RX. You have to connect the output waveform, which is this. Okay, and finally you have trellis graph RX, which sorry, just have to make sure I connect everything here. Yep. Yeah, trellis graph RX. You just have to connect this. But this is the RX, hence you will connect the output waveform itself. And that should be the end. Yep. That should be the end. You see a broken arrow here, something's missing. Bundled by name connects. Oh, there you are. You missed this. And this should also work. And no. There you are. I seem to have missed these few lines here. Pulse shaping filter coefficients and sync found index. I completely missed it. Clearly I'm very sleepy. Yeah, that should do the job. No. Well, it turns out I made one small misconnection, and yeah, you will barely notice it unless you have to go through the entire thing again, which is the only pain point in this. But I believe now it should run. This is the already working one. This is what should run smoothly now. There you are. That is your final graph. Your dot should look like this. Transmitted, demodulated, everything should look like this. Wow, that was one hell of a speed run. But yeah, now that everything and all the processes are in one place, I hope that makes things a lot clearer for you. All you have to do now is just go practice for like an hour, hour and a half. All of these, it'll just make sense, and free lab view marks for everyone. All right, see ya.